In this video today, we are going to be looking at linear functions, and specifically in this video, I'm going to be talking to you guys about slope. But before we get into there, I just want us to take a look at this warm-up problem where it says, what is the power for this x? Another word for power is exponent. So that's that tiny number that floats above a variable. So if this is my x, what is the exponent that is above it? Well, if there isn't an exponent there, like this x doesn't have a number here, then you can assume that that number is always 1. Just like you can assume the number in front of this x, the coefficient, is 1. So because this exponent here is 1, we're just going to put 1 here as the answer. And this is really significant because in algebra, I'm going to be teaching you all these different kinds of function. We're going to do x to the first power starting off in our first chapter. And then later on, we're going to talk about x to the second power and x to the third power. And then it just keeps going upwards from there. So whenever you have x to the first power, this is what we call a linear function. Linear connects with the term line. So when you have a linear function, you might remember like this slope here is 1, so it goes up 1 over 1, and it forms this linear or this kind of like a straight line, like that. So that's what we call a linear function, is when we graph a function and it looks like a line. So it doesn't have any curves. And so this is also what we call, so this particular function, notice it doesn't have anything fancy. This function is just y equals x. It doesn't have a plus 1 here, or this doesn't have a 3x or a minus 1 to the side. This is the original function for a linear function. So any function that doesn't have, like it hasn't been shifted, is what we call the parent function. So nothing about that function has been shifted. So this is what we typically call the simplest form of that type of function. So this is the parent function for linear functions. So like I said before, the function hasn't been shifted. And so now that we kind of talked about this is a linear function, let's talk about the slope. The slope is usually a number in front of the x, and typically we call it or refer it to as m. So typically when you have a linear function, it looks like y equals mx plus b, where m here is the slope. B we'll talk about next time, but we refer that as the intercept, or specifically the y-intercept. But today we're just going to talk about the slope. So slope is always rise over run. Rise is talking about how many times did it go up, and then run is telling how many times it went over. So in this case, it went up 1 over 1 because the slope here is just a 1. And the formula for a slope is y2 minus y1 and x2 minus x1. Essentially, if you have two coordinate points, so notice right here there are two coordinate points. We'll call this first one x1 and the second one y1. And then this other coordinate point, we're going to call it x2 and y2. If you have two coordinate points, you can use the slope formula to find the slope. And we always put y's on top because y's show you the vertical shift, which is the rise. And we always write x on the bottom because x's show the horizontal shift, and that is the run. And so let's talk about different types of slopes. So if you ever have a positive value for a slope, so in this case you had a positive 1 here, notice how this line is increasing. It's from left to right, it is going upwards. So if you have a positive slope, it's going to look like this shape. If you have a negative slope, it's going to go downward. It's going to decrease. So this is increasing if it's positive value for the slope, or negative means that it's decreasing for the slope. Now, if you have a slope of 0, it's going to look like a flat line, kind of like this. So this is what we call a horizontal line. So anytime the slope is 0, it is a horizontal line. You're going to get that flat line because there is no slope. It's not going up. It's not going down. It's going to stay leveled. And so another one here is when you have something undefined. So this will happen every now and then, is you're finding the slope and you notice that the bottom, the run is 0. Anytime the denominator is 0, you got something that's undefined because you can't divide by 0. So in that case, you're going to get a vertical line instead. And that's all the 4 different types of slopes you can get. So let's talk about just looking at finding slopes on a graph. So I'm going to shift this up a bit. Let's take a look at example 1 here. So in example 1, I've already drawn, or we have some lines already drawn for you. And what you have to do is determine the slope of each line. So you're trying to find basically the M. And remember, that's going to be the rise over the run. So what we can do here to figure that out is to take a look at the graph. And what I like to do is look at the line where the points are clearly easy for me to see the coordinates touch those intersections. Like this one right here touches that intersection really nicely. So I'm going to use this one as a coordinate. And then I'm going to look for another one. Like that one doesn't really work because it kind of hits it really close, but not quite at an intersection. So I'm going to keep going up, and like that one works really well because it hits that corner or the intersection. And then from there, I'm going to grab a highlighter so that way you can see this clearly. So if I'm looking at these 2 points, let's draw a line or triangle that connects them. It looks like kind of like a triangle, right? So let's see here. We need the rise. So this is the rise here. If we count how many boxes that is 1, 2, 3, 4. So I have a rise of 4. And notice that this rise went up, right? So I'm going to put a +4 here. So from this point to this point, I notice that this point is higher, so it's going upward. So this is a +4 for the rise. Now for this side here, it's going from left to right in the positive direction as well. So let's count. That's going to be 1, 2, 3, 4, 5. So that is 5. And so that's also positive. So it looks like my slope here is 4 over 5. And that is my answer. So that's my slope. And just so that you guys know which way is the positive direction and the negative direction, remember, your y's are always positive if they're going upwards, so up on the y values. And if they're negative, they should be shooting downwards here. And also, this side is positive for x, and this side's negative for x. All right, let's do one more here. This one gets a little interesting because it's kind of sloping downwards, right, instead of sloping upwards. So again, we're going to look at 2 points that might be easy to read. Like that one's pretty easy to read. And maybe this one here. So if I were to draw, again, my triangle and try to connect those two, I'm going to have to go down and over. And because I noticed I went down, my rise is going to be negative. It went 1, 2, 3. So that's a -3 because I went down from this point to this point. Now, it looks like I'm still going in the positive direction from this point to this point. So that's 1, 2, 3, 4, 5, 6, 7, 8. So that's like a +8 to the right. So my slope here is going to be -3 over 8. And there we go. We have our slope. Okay, so that's how you do it with a graph here. What if you got a problem where you don't have the graph, but you have the coordinate points instead? So in that case here, you're going to have to use that formula that I gave earlier, which is the y2 minus y1 over x2 minus x1. And so those x's and y's are the coordinates. So if this is my first point, I'm going to call that x1 and y2. Or sorry, not y2, y1. and this one x2 and y2 because that's my second coordinate. And so I would just follow along the formula here. So m, the slope, equals my y2 minus my y1 based off the numerator. So my y2 is 0 minus my 5, which is my y1. Take my 8, which is x2, minus my x1. So that's going to be 8 minus 3. Notice there's a subtraction sign between them. And so this will equal negative 5 over 8 minus 3, which is 5. And, oops, sorry, that's my highlighter. And if I look at this here, 5 over 5, remember, fractions is basically division. So if you were to divide 5 into 5, you get 1. 5 divided by 5 is 1. But in this case, since there's a negative sign here, we're going to have to write a negative 1. So the slope here is negative 1. And that's it, guys. So let's try another one here. So for this one, again, this is going to be my x1, y1, x2, y2. And by the way, it wouldn't have mattered if I called this one my x2 and y2 and this one my x1. It really doesn't matter as long as you follow the formula correspondingly. So let's do this one here. Sorry, I need to grab my eraser. I'll just scribble that out. So my y2 here is 1. My y1 is also 1. And then my x's are 8 minus 3. So if I subtract the top, 1 minus 1 is 0. Subtract the bottom, 8 minus 3 is 5. But here's the thing. If 0 is on top, 0 divided by 5 is actually 0, right? So in this case, I have a slope of 0. But we mentioned this before. If you have a slope of 0, that means you have a horizontal line. So the line is going to look like this on the graph, whereas the one before had a negative slope. So this one is going to be decreasing, and the slope is going to kind of look like this, where it's shifting downwards as it moves to the right. And then our last one here, let's figure out what this one is. So again, I'm going to set up my slope formula. I'm going to take my y's. So that's going to be y2 minus y1. So taking y2 minus y1. And then I'm going to take my x2 minus x1. So that's going to be 5 minus 5. And so my top here is going to be 6 if I subtract, and my bottom is going to be 0. But hang on, anytime I have a 0 in the bottom, I can't divide by 0 if it's in the denominator. So this is what we call undefined. And if it's undefined, you have a vertical line. And a vertical line is going to look like this. And that's it, guys. So hopefully this helps you have a better understanding of how to find slopes on a graph and how to find a slope if you are only given 2 points. Okay, for the next video, I'm going to show you how to look at if something is linear or not.